are going to start the lecture on nanotechnology in chemical engineering. So, today we will discuss about synthesis of nanomaterials. So, in this a few techniques we will discuss. So, in our previous class we have discussed a few mechanical methods, that is high energy ball milling and melt milling technique. So, by that way these are the physical methods. So, that way we can prepare this type of nanomaterials. So, today we will discuss basically the method based on evaporations. So, we can take any solid materials and that can evaporate and then would be deposited in terms of films or in terms of nanoparticles. So, then that can be used as a nanomaterial for various applications. So, today basically physical vapor depositions or PVD with consolidations, that will be discussed. Ion cluster beam depositions, that is another evaporation method that will be discussed, and then laser vaporizations or laser ablations method, that will be discussed to prepare nanomaterials, and then laser pyrolysis. These are the things will be discussed in these lectures. So, many methods are techniques that is are available to synthesize different type of nanomaterials, that already we have discussed in our previous class also. So, some existing or conventional methods are there, and these methods are optimized, and then some new techniques are been developed and that are used to synthesis different type of nanomaterials. Okay. So, depending upon our target materials, so a particular methods we can choose to synthesis that particular nanomaterials. So, I said that variety of methods that form nanostructures by evaporating, and today whatever we are going to discuss, that is evaporations method, and through evaporations the materials, target materials, that would be evaporated out with the source of some heat or other things. So, that will be deposited in a particular surface where we need to deposit that particular materials in the form of films or maybe in the form of nanoparticles. So, nanostructure materials I said that may be in the form of thin films or multilayer films, or maybe nanoparticles in the thin films that will be deposited, or a thin particulars over the substrate, that particular layers of nanomaterials in the form of nano particulate thin films that will be deposited or that will discuss. So, over the substrate these films may be, depending upon our applications, its one layers formations would be theirs, or maybe multiple layers formations depending upon our objective or target materials, where we want to deposit that particular layers in one layer single layer thin films, or maybe two or more or multiple layer formations over the surface, that we can decide depending upon our applications. Okay. So, in this particular process actually when we are doing or evaporations method we are using, so then first we have to conversions of that materials or targets that into vapor, and then subsequently condensations. Okay. So, first we have to heated up that materials or target materials that converted into vapors, and then in any cold surface or substrate where we want to deposit that, that would be condensations in the form of nanoparticles or nanofilms. Okay. So, I said that materials of interest that would be in the vapor forms or gaseous forms, that is maybe in terms of atoms or molecules, and that molecules if very fast formations and depositions, then it would be very small atomic states or molecular states, and if it is wet then it would becomes cluster formations, that atoms or molecules whatever that converted into vapor, bigger size or cluster formations is there, and then it would be deposit on the over a particular surface. Here a scheme is showing here. So, here one heated crucible was taken. So, over there that substrate or that materials that we want to evaporate out by heating, that may be conventional coil heating or element heatings or maybe laser heating. So, that would be evaporated that material, and then that atoms or molecules whatever that would becomes a larger particles or clusters, and then it would be into nano particles forms that would be collected in any cold surface. Means here's one surface would be there, that is cold surface, there these clusters will be deposited, and then later we can collect it from that surface. Okay. So, here one example is showing, so how we can prepare the zinc sulphide nanostructure material. So here is systems is there. Here this is the furnace, this furnace, and this is tubes, that may be ceramic tube or maybe quartz tubes that would be taken. So here is the source material. So if your target is zinc to zinc sulphide formations, let us say zinc sulphide vapor that would be deposited, or we want to make that. So initially you have to take zinc here inside of that furnace. Here we can put in a crucibles, or there we can place that zinc metals, and then it would be heated up at a desired temperatures, and then carrier gas that would be flow. With that carrier gas, here we can pass as per our objective to prepare zinc sulphide nanostructures material. So then it would be H2S gas that would be passed through this, and then they will be reacted at this particular temperatures, and then that would be deposited over the surface. Okay. So here's vacuum pump is there also, before that, to eliminate any contaminations during these reactions, means zinc plus H2S to zinc sulphide, so that would form. So if any oxygens or other contaminations here is there, then pure zinc sulphide will not get, zinc oxide or other things might possibilities there. So to any eliminations of any contamination, so we have to use some vacuum pumps to have vacuum that systems before charging or passing or heating up that zinc. Okay, so this way we can prepare this particular metal sulfides by using these evaporation methods. So in this particular methods, there are many parameters, that is controlling parameters, that is the system pressures, system temperatures, reaction times, and source and substrate materials. That is very important. So which particular source we are taking, on which substrate we are depositing, system temperature, pressures low or high, and reactions times, that may be very fraction of times or maybe very long times. So depending upon that, the materials will be formations. Okay. So next is the heating. Since I said we have to, before reactions are conducting evaporations, we have to make that systems vacuums. So in these methods, there are many methods. Heatings means when that materials will be heated up, so that's target material. So resistive heating is there, electron beam heating is there, laser heating is there, sputtering methods, these are the there. So here's these are the, when the heatings means here in these materials, here we have taken that our target material. So that materials we can take in a crucibles or boat. Okay. So in that place we can hold that materials for evaporations, and that heating up would be with the help of filaments we can use, or else we can use electron beams. So each particular methods is, means this filamental heating method is much cheaper, or electron beams that also we can use, that may be costly, but it's less contaminations or impurities of that materials. Means so when we heat it up, that less contaminations or impurities in the target or final products, that possibility is less. Here we have to use crucibles or boards, so that may be react or interact with the target materials or substrates. So at that high temperature, that possibility is there in this case, but in this case contamination is less. Okay. So these are the things we will discuss more details, filament heatings or electron beam heating. And I said also that controlling parameter is very important. So these are the controlling parameters to get that desired substrate or target or product materials in the form of nanofilms or nanoparticles. Okay. So in filament heatings, so we have to use some crucibles or boards that would hold that materials that we want to evaporate out from that particular temperatures or high temperature. And before that, I said vacuum is very important, systems vacuum. Why vacuum is important? Means to avoid uncontrolled oxidations of the source materials and final products. So that is one of the primary objectives, to create the vacuums in that particular systems. In evaporations operations will be going on. At the same time, when there is a vacuums is created, then mean free path of the particles that will also increase. As a result, we can get a good particles, means controls that we can get, means easily to be evaporated and very fast that would be deposited on the target substrate where we want to deposit that. Also, even if some reactive gases also we can use, depending upon our method or target materials that we want to get. So some reactive gases, means here in our previous slides I have shown, H2S that was used as a reactive gases with zinc metals. If we don't use H2S, that is reactive gases, so only zinc metals that also can be evaporated out, and in that particular metals will be deposited over the target substrate where you want to deposit. So if you don't use that reactive gases, so if reactive gases pressures also, that is also very important. So that also means pressurized systems to desired value of introducing the high purity gases in this particular chamber. So I said, or this particular chamber, here that gases we are going to use are going to passes through this during evaporations or vaporations of that materials. So that pressure means indicate that concentrations of that materials depending upon that, that will change. Okay. And filament heatings, I said that filaments, different type of filaments here it is showing. So that is the source of actually heating. So means we have to heat it up that materials within very short period of time. So then different type of heating arrangements or coils or filaments are there, or else we can take that materials in a particular type of crucibles or baskets. There we can take that particular materials in different type of means content, the amount means the target material very small quantity or depending upon large quantity, each particular shape of basket or vessels, or you can say crucibles, we can use, or container you can use to take that particular materials we want to evaporate out at that particular temperatures. Next is that electron beam heatings. So in electron beam heatings, so electrons beams that would be focused on that materials, on that particular materials, that beams generates high temperature and metals will be evaporated out from that particular crucible, and then that vapors will be deposited in a cold surface. There we can get that particular films, nanofilms and nanomaterials and nanoparticles that will be deposited when in cold surface. So in this particular electron beam method, I said less contaminations or less impurities, since a particular, let us say this is our crucibles, here we have taken our substrate. So lasers will be, laser beam or electron beams that will be fall over here at particular points, that would not be come into the surface of crucibles. So therefore less contaminations possibility is there. So that contaminations part we can avoid by targeting a particular small portions of that particular substrate. Electron beams will be focused and that material will be evaporated out from that particular locations or points. Okay. So next is the materials what we are going to evaporate, system pressures I said, that is also very important. So to depending upon applications, low highly vacuum systems means low pressures we can achieve. So and some metals, that is titanium, molybdenum, iron, silica, here few example I am showing. So this particular material having high or large vapor pressures. Okay. So then these materials we can evaporate or sublimate very easily at a particular temperature from that substrate crucibles where we have taken that materials. There are some other material, that is gold or silvers, that having very low pressures. So that need to be melted to achieve vapor pressures, since adequate vapor pressure that we need to evaporate out that metals means for the depositions. Okay. So means few metals having low vapor pressures, few metals having high vapor pressures. High vapor pressures, those metals easily can be evaporated out, and those having very low pressure, so that first will be melted and then it would be vapor out from that particular substrate. Okay. So next we will discuss about the details about the physical vapor depositions, and in this particular methods we can synthesize or develop low porosity pellet formations. So we can make pellets, and there's the porosity of that particular pellet should be very low porosity. So here in physical vapor depositions method, so here in right hand side one schematic diagram is showing. So in this particular method, step by steps how we can make that materials means our target pellet with having low porosity. So in this methods, in vacuum chamber is there, this is vacuum chambers, and then cold finger is there, this is the cold fingers, means here's liquid nitrogens we can pass here. So in this particular source or point where substrate will be deposited, so this is cold fingers. So liquid nitrogen low temperature is maintained. So where our materials will be, here is the crucibles, these crucibles where high temperature will be maintained and that target materials will be evaporated out under vacuum conditions. Okay. And then it will be deposited in the cold surface, that is cold finger is there, and then we will collect the condensed nanoparticles without breaking the vacuums. One scraper is there. So this is the scrapers, these scrapers that would be go up and downs, and by that way, so whatever the nanomaterials will be deposited over this surface, that will be taken out and collected here. Okay. So at the bottoms there is one piston anvil cell is there, that would be whatever the nanomaterials will be collected, that would be after scrapping or using the scrapers we can collect it here, and then it would be come to the piston anvil cell. So where we can develop high pressures, and then that powders nanoparticles whatever that was forms, that would be densed and low porosity under pressure, that will be developed and that would collect from there. So at the bottoms. Okay. So piston anvil cells is there. So okay. So in this key parameters of this particulars physical vapor deposition, see here evaporation rate and the chamber pressures that control the particle size and distributions. Evaporation's rate and chamber pressure. So there is a vacuum chamber I said, so that we have to use, and that vacuum pressures we can change as per our desired values. And evaporation's rate also, that depends on the how fast we are heating, so that also depends, and that also control the particle size and its distributions, means smaller to higher different ranges of nanoparticles that may forms. Okay. And in this particular process we can do the repetitions, means evaporations, condensations, both cycles will be done simultaneously, means first metals or that materials will be evaporated out and then it would be condensed with the cold fingers or cold surface, and this process will be continuous, and by that way the desired amount of the materials we can prepare within a stipulated or sufficient times we can spend and we can get. Okay. And high vapor pressure metal oxides, here one example is there. So we can evaporate or sublime, and then that using board or filaments, these type of metals, I think tungsten, thallium, molybdenum, that we can take in a boats, and then we can evaporate it out and then condensed, and initially that materials whatever that metals you have taken, that would form in atomic stage, and then it would be form clusters and bigger particle size would forms, and then that would be deposited from the surface, cold surface. Okay. So any reactive gases also I said that we can use inert gas or inert atmospheres we can maintain, vacuums we can maintain, or any reactive gases also we can use depending upon the materials we need to prepare. So that may be oxygens, hydrogens, ammonia, that also we can use. So if we use oxygens, then we can get metal oxides. If we use ammonia, nitrites or hydrates materials, if we use hydrogen, that we can get. So I said that size, shapes and phase, particular phase, so of that materials we are going to prepare by this evaporation condensation methods or PVD method. So there's that depends on the gas pressures in the deposition chambers. For example, the hydrogens, when it was 500 kilopascals pressure that was used, so then TiH2 particles that was from, that was 12 nanometers produced, and that would be later converted using this oxygen gas, let's say. So TiO2, TiH2 converted into TiO2, means initially titanium metals was there in presence of hydrogen, TiH2 is formed at this particular pressures, and then that TiH2 by reacting with the oxygens it would be converted into TiO2 by using oxygens. Okay. So this is PVD method that we have discussed. Next we will discuss about ion cluster beam deposition method. So in this particular methods we can synthesize single crystalline thin film formations or thin films we can produce by this method. So here also similar type of things are there, means in ion cluster beam deposit method. So here evaporation chambers is there, so where materials will be taken, and here furnace is there, so or heater is there. So this is the heating elements outside of this chambers, evaporation chamber, that would be heated up, that metals, or then ionization chamber is there, and then accelerations and then ions will forms and that will be deposited over this. This is our substrate. Here you can see that yellow globules or spherical particles that would be evaporated out and deposited over the target coal surface. That way it can deposit it. Okay, so here's produced in this particular methods we can produce the high quality adherent single crystalline thin films. That is the good things, and these setups already we have discussed. So here's electron beams that would be used to ionize that cluster. So whatever the clusters that would forms, so an electrons beams will be applied over that, and then that would be ionized, and that ionized to cluster formations would be theirs. Okay, in this is the procedures and this is the challenge. So in this case process, first molten materials forms clusters that would expand through these nozzles. Here is the nozzle, so through these nozzles that would be coming out, and then the clusters would forms that molten materials, and then that are ionized by the electrons beams and directed to the substrates using accelerating voltage. So here's accelerating voltage is there, so means another systems is there, that would be that ionized materials will be directed towards the substrates by accelerating voltage, and then nanocrystalline films that would be forms that would be deposited over the surface. So by that way we can collect that materials later, and these particles size distributions will be uniforms as clusters are not mass selected. Okay, so therefore the particles, whatever the particles will be deposited over the surface, that is not uniforms particle size as clusters are not mass selected. Okay, next is the laser evaporation ablations method. So in this particular method we can prepare single one carbon nanotubes, that is very costly methods or laser ablations method. So in this methods pass laser beams of high powers that would be used, a high energy lasers that will be vaporize the target materials forming nanoparticles, and without stabilizing agents also we can operate that systems. So here's that systems we have to use, means for this laser ablations ultra high vacuum chambers or high vacuum systems that we have to use. There we can use inert gases that would be present in that particular chambers, where also similarly coal substrate would be there. So the cluster materials that will be forms that would be deposited in that particular substrate or points, so there we can collect. Okay, so here also similar systems is there. So here we have a, here we can put that substrates, means materials we have to use, that is the target materials, laser beams will be fall over there, and then plumes would be formed and that would be deposited over the surface. Okay, so here in this ultra high vacuum chambers, this is ultra high vacuum chambers that we are using. So here excited monomers lasers is used in this particular case. So there are various type of excimer lasers are available that we will discuss later. Inerts or reactive gases that would be placed here in this vacuum chambers. Then laser beams, I said laser beams we have to fall over the targets, and then cold fingers is there or cold substrate is there. So there it would be deposited. Okay, so here various types of excimers lasers are available. Okay, so these fluorines ERF, krypton chloride, krypton chloride, xenon chloride, different wavelengths, so that is available. So depending upon that source available excimer source, so that we can use. So vaporization materials, that is very important, which is affected using pulse laser beams of higher power or high powers. Okay, and gas pressures, that is also I said that is very critical in determines particle size and distributions of that particles over the surface. So therefore in when we are using the gas, a particular gas that may be inert gas or other gases, in the that pressures is very important. Okay, so by controlling that we can get different type of materials. Okay, next is we are going to discuss, that is laser pyrolysis method. So in this particular method we can prepare thin films using lasers as the source of heating, and also many nanoparticles we can prepare by this way. So here's a mixture of reactant gas that we have to use, and that reactant gas will be decomposed using lasers. It is one kind of in absence of oxygens or air, so some inert gas we can use. Okay, in this particular process it is called laser pyrolysis method. So pyrolysis means in absence of oxygens we can heat it up that reactant gases or organic substance or anything. So by using laser source. Lasers would be used as a source of heating. First, the inert reactant gas molecules that would be decomposed and colloids with the inert gas atoms. So, we are using reactant gas plus some inert gas, both will means inert reactant, that reactant gas will be decomposed and that will collide with the inert gas atoms that are we are going to use, and they interact with each others and grow and then deposit on the cold surface. Okay. So, here also similarly gas pressure is very important. So, here you can see this is the gaseous molecules, let us say this type of things we can use. So, here these gaseous molecules in presence, this is laser beams. So, when laser beams interact with these gaseous molecules, it would be decomposed or pyrolyzed, and then what are the pyrolysis substrate will forms, that is carbons here in this case, that would be deposited over the surface, and then we can get a thin films of that particular surface. Here it is, if it is carbons organics, then carbons thin films we can produce. If it is aluminum oxides, then aluminum nanoparticles, tungsten carbide, these are the metal nitrates, silicon nitrates that are tungsten carbides, aluminum oxide, depending upon that materials you have taken that form the fumes that we can deposit in the form of thin films. Okay. So, that we can prepare through this method. So, we have discussed so many methods, so by which we can prepare different type of nanomaterials, nanoparticles, nanofilms. So, individuals methods, that is very important depending upon that applications. Okay. So, thank you. So, today is up to this. Thank you.